In this video, I'm going to talk about classes as they exist in C#. They are very similar to classes in C++ and Java, which you've seen before you got to this class. There's a couple of little differences that I'll get to, but the fundamental concepts are identical. So you can think of a class definition as a blueprint or a cookie cutter. The blueprint itself is the class, and then the instances are the houses you make during using the blueprint. Right? Your class is the cookie cutter, and you're going to use the cookie cutter to stamp out instances of that cookie. So that's how we can think of a class. A class is a template or a blueprint for an object. And the instances are the individual objects that we make using that class definition. And Visual Studio has amazing code completion. If you're starting to write a class, just type the word class, hit tab twice, Visual Studio will stub out a class for you. So very, very helpful. What kind of things do we find in a class? Typically, a class will have variables that represent its state. It will have properties. Properties are very much like variables. I'm going to get to properties in a separate video. Functions and constructors. There is no such thing as a destructor really in C#. There's something called a finalizer that if you use the tilde notation, you can write something that looks like a destructor. However, that's actually called a finalizer, and it gets called when that object's dispose method is called. So it's not really a destructor like it exists in C#. The only reason you would write a finalizer is if that object has some resource that it needs to release prior to being destroyed by the garbage collector. We're going to get to finalizers later. And then I have a whole video on properties. Properties are kind of getters and setters. They're related to that. Also, we have the same access modifiers that we do in C++ and Java. We have public, private, and protected. And I'm going to just review when you would use those particular access modifiers. If you don't put an access modifier on something, it becomes private. So for safety, the compiler will slap on the most restrictive access modifier that it knows, which is private. And one way to think about a class is, I like the vending machine analogy. So there's a public interface that you as the guy or person who is hungry wants to interact with, and then there's all this machinery behind the scenes of that vending machine that does what vending machines do, but we don't really know how it works. It's abstracted away from us. It's behind the interface. So we don't want somebody to be able to go in and grab out all the candy bars. We don't want them to be able to grab the Diet Cokes and take all the money and wreak havoc on the vending machine. So we have a clearly defined public interface for that vending machine, and the machinery itself, how that vending machine works, is private or protected. So that's the purpose of access modifiers. It's to make sure that objects have consistent internal state. So that's the whole purpose of this is protecting state. What goes on inside that vending machine, we don't know. It's abstracted away. That vending machine encapsulates all of the stuff it needs to know to do vending machine things, right? So those are some object-oriented terms thrown in there so you can sound smart on interviews. Public is the least restrictive access modifier. If something is public, anybody can come and change it, or if it's a function, anybody can call that function. It is lazy, bad programming to make everything public. Private is the other end of the spectrum. If something is private, it is meant for internal state keeping only. That is the stuff that's inside the vending machine that the public, the hungry people are not allowed to interact with. Anything that is private can only be used called or accessed from within that object or from with other objects of the same type. So no, you can't access a private function in an object. You will say that function is unavailable based on that function's access modifier. So you'll get an error message if you try to call a private function in an object. And we'll get to this when we get to object-oriented behavior. If something is private, an object has private things, and you derive a new class from that object, you still can't see the private stuff. It seems like you should be able to, but you can't. It's private. It's meant for that object, the base class alone. And It's not available to anybody but that object. If something's private, it belongs only to that object. So there's an access modifier that's kind of halfway between public and private, and that is protected. So protected is not accessible by the outside world. However, it is still available to derived classes or subclasses. So if there's a class and you go make a new class that inherits from it, you have access to the protected stuff. So I don't usually use private a lot. I use protected and public. Again, because you never know if you may need to subclass an object. And then just to recap, a class is really kind of represents a logical object, a kind of a logical grouping of functionality, and that object contains functions that allow that object state to change, and it has variables, properties, private data that represents that object's internal state. Properties are the equivalent of a getter and setter in C++ and Java. I have an entire separate video on properties. The syntax for properties is a little weird until you get used to it, but once you've learned to use properties, you will love them, and they will provide you will immediately see the benefits to using properties. So make sure you watch the video on properties. What else do we find inside of a C# class? We will find constructors. Constructors are special functions that initialize an object or set an object to its default state when it is created using the new operator. It sets an object's properties variables to their default values. And this is used in conjunction with the new operator. When you never just call a constructor like you would call a function. You always use a constructor in conjunction with the new operator, because you have to allocate the memory for the object before you can then go initialize that memory. So constructors are used in conjunction with new because you have to allocate memory. There are two ways to spot a constructor. Constructors always have the same name as their class, and there's no return type specified in a constructor, and that is because they implicitly return you that type of object. If you're trying to make a thing, right, it's just understood you're getting a thing back. So those are the two ways to spot constructors. They have the same name as their class, and there's no return type. At Visual Studio, again, autocomplete to the rescue. CTOR, hit tab twice. Visual Studio will stub out a constructor for you. Here's an example of a constructor. So here's a class called widget, and here's a public constructor called widget. And you can see that this constructor has the same name as its class. And you can see that there is no return type there, right? So it implicitly returns a widget, right? That should say widget. So that's two ways to spot a constructor. Those are the two tip-offs. And then I just said constructors are always used in conjunction with the new operator. All right, so this top line, I don't think anybody would do that in this class. It might make sense if you're new to these object-oriented languages, but anytime you create an object, you're going to use the constructor in conjunction with the new operator, because we have to carve out the memory for that object before we can initialize it. Just like in Java and C++, if you do not provide a constructor in a class, you will get a default constructor. The compiler will generate a default constructor for you. Otherwise, you'd never be able to create the object. And that, again, that's just like C++ and Java. Also, like those languages, you can overload constructors. So you can have many constructors, as many constructors as you want. They just have to have different parameter lists. And objects frequently do have multiple constructors because there may be different ways you want to create that object. So here's an object that has two constructors. You can see we've overloaded the constructor here. So the class is called SomeObject, and you see we have two constructors here. One takes no parameters, and the other takes 3 parameters. So you can have as many constructors as you want. The parameter lists just have to be different, that's all. And just like C++ and Java, we've got the concept of instance scope versus class scope. Or does a piece of data belong to an instance of a class, or is there one shared copy that every instance is using? So usually things are instance variables. So imagine we're writing a Space Invaders game, it makes sense for every Space Invader to have its own coordinate. Like they don't want to all share a coordinate. That doesn't make any sense, right? So those would be called instance variables. It's X and Y coordinate on the screen, right? That would be an instance variable. Every instance has its own copy of that variable. And when you just declare a variable in a class, it is an instance variable. However, we can give variables a class scope, meaning they belong to the class as a whole rather than any individual instance of the class. This is referred to as a static variable, which is not the best name because static kind of implies that it's not changeable. Static stuff can change, but what static really means is shared. So if something is static, it means there's one shared copy that is simultaneously used or is available to every instance of the class. So if there's a million Space Invaders and they have some static variable, that means they all are sharing the same copy of that variable. So static doesn't mean it can't change. Static means there is one shared copy. In fact, in VB, the keyword for static is shared, which makes a whole lot more sense. When you are referencing something that is static, because it has class scope, you use the class name rather than an instance name, and the compiler will enforce that. In C++, I remember you could do it either way, and the compiler would just kind of say, okay, I know what you mean. But in using Visual Studio, anytime you are accessing something that is static, you have to use the class name rather than the instance name. So the math library is full of static stuff. And so here you can see that if I want to use pi, I have to say math.pi. Math is the name of the class. Like we didn't create a new instance of the math library, right? Math is the name of the class. So to use a static variable in that class, we use the class name. And that's kind of our way of knowing, oh yes, it's class, it's scoped to the class, right? There's one shared copy of that. Now, this makes sense, but you might not know it. When you make something constant, unchangeable, it automatically becomes static. And the reason for that is generally, const is to make something constant. So if you have a million Space Invaders, does it really make sense for them to share the same, each have a copy of a constant? No, it makes much more sense to have just one constant that they all share. So when you make something const, it automatically becomes static, and you have to access it using the class name. So actually, if you go back to the slide about math and pi, pi is declared to be const because you can't change pi. And although people have tried, amazingly enough, and because it is const, it becomes static, and therefore we have to use the class name when we want to use pi. We have to say the class name instead of some instance name. So that's it. Now, I would say that the next thing we're going to do here is before we get to snail races, let's watch the video on properties. You can understand how properties work before we get to the snail races. The snail races example will use properties. Properties are a type of getter and setter. Once you get past that little bit of kind of syntactic weirdness, you will love properties. You will see the benefits, the glorious benefits of properties. So that's it. Classes work very much the same as they do in C++ and Java. The only thing that'll really be different is that we don't have destructors in the strictest sense, and you are going to see properties much more than you will see getters and setters. But if you have any lingering questions about C# and classes and how they work, or specific questions, just email me. I will be happy to reply and alleviate all your confusion. So I would say the next thing to do would be to watch the video on properties, and then after that we'll get to the snail races, which is one of my favorite activities.